guys, hope you all are doing great. Today we are going to see detailed solution of K 2005 and 6 questions on set transform. After all, it's an important topic that is included in many competitive exam syllabus, and practicing previous year questions will definitely help you to perform better in upcoming GATE exam. So without further wasting time, let's get started. The question I have for you is from GATE 2005. The region of convergence of set transform of the sequence 5 by 6 whole raised to n u of n minus 6 by 5 whole raised to n u of minus n minus 1 must be option A mod set less than 5 by 6, option B mod set greater than 5 by 6, option C 5 by 6 less than mod set less than 6 by 5, and option D 6 by 5 less than mod set less than infinity. Let us consider 5 by 6 whole raised to n u of n as x1 of n and 6 by 5 whole raised to n u of minus n minus 1 as x2 of n. So our desired sequence x of n can be written as x1 of n minus x2 of n. Next, what we are going to do is, first we are going to find out Z transform and ROC of x1 of n, then that of x2 of n. Finally, we combine these two to get our desired ROC. Got it? The Z transform of standard sequence a raised to n u of n is set by z minus z with ROC mod z greater than mod a, where a is a constant with 0 less than a less than 1. Based on this, we can write set transform of x1 of n 5 by 6 whole raised to n u of n as set by z minus 5 by 6 with the ROC mod z greater than 5 by 6. On the other hand, set transform of the standard sequence minus a raised to n u of minus n minus 1 is set by z minus z with ROC mod z less than mod a. So we can directly write set transform of x2 of n minus 6 by 5 all raised to n u of minus n minus 1 as set by z minus 6 by 5 with the ROC mod set less than 6 by 5. Thus, we obtain set transform and ROC of x1 of n and x2 of n. Next, what we are going to do is, we are going to plot these two ROCs. Let us first concentrate on x1 of n, that is 5 by 6 whole raised to n u of n. Its ROC is already obtained as mod z greater than 5 by 6. How can we plot this ROC? In fact, mod z greater than 5 by 6 represents the area outside the circle of radius 5 by 6 in z plane. You can see it here. The shaded region represents ROC of x1 of n. Moving on to x2 of n, ROC of x2 of n is obtained as mod z less than 6 by 5, which represents the area inside the circle of radius 6 by 5 in z plane. The shaded region here represents ROC of x2 of n. So we plotted ROC of x1 of n and x2 of n. What is our next task? Our next task is to obtain ROC of x of n, that is x1 of n minus x2 of n. If ROC of x1 of n is R1 and that of x2 of n is R2, then ROC of x1 of n plus or minus x2 of n is R1 intersection R2. We obtained ROC of x1 of n as area outside the circle with radius 5 by 6 and that of x2 of n as area inside the circle of radius 6 by 5. When we take intersection of R1 and R2, we get ROC of our desired quantity x1 of n minus x2 of n as 5 by 6 less than mod z less than 6 by 5. You can see the shaded region here. Thus, our answer is option C. Got it? Let us move ahead and see next question is from K 2006. If the region of convergence of x1 of n plus x2 of n is 1 by 3 less than mod z less than 2 by 3, then the region of convergence of x1 of n minus x2 of n includes, for options, option A, option B, option C and option D. If x1 of z is the Z transform of x1 of n with ROC R1 and x2 of z is the Z transform of x2 of n with ROC R2, then ROC of Z transform of x1 of n plus or minus x2 of n is R1 intersection R2. So we can say ROC of x1 of n plus x2 of n and x1 of n minus x2 of n are same. Thus, our answer is 1 by 3 less than mod z less than 2 by 3. That is option D. Thus, we are at the end of this session. Hope you all enjoyed it. Thanks for watching. Thank you.